All right, so we're in section 1.4, and we are interested in solving a rational equation in example 2. So in solving irrational equations, you may want to review section P.5 in where you had to find the LCD, the least common denominator of rational expressions. So the difference here is we're dealing with rational equations. But either way, both these sections, you're going to have to deal with the LCD, which is identical. So you may want to review section P.5. Now, in finding the LCD is identical, but what we do with the LCD after we find it is different. Now, let's go into, so go ahead and review P.5 if you need to review the LCD of rational expressions. So now, assuming you understand how to do that, we're going to work through finding the LCD pretty quickly, and then focus more on the what we do with it. Now, both of these examples actually are pretty simple in terms of finding the LCD. So, because in this case, we only have one denominator. So, well, we have two denominators for A and two denominators for B, but they're the same thing. So these are trivial cases, but in this case, the LCD for A is equal to x plus 4. Now, there could be more to it. There could be more to the LCD, of course. If you review P.5, you'll see that it may be more complex. But you always do the same thing with the LCD. But just a property of the LCD, so notice what we want to do with the LCD is we want to multiply both sides of the equation by the LCD. So I'll rewrite this. 2x plus 1 over x plus 4. I'm just going to rewrite it down here so we have room. That's equal to negative 2 over x plus 4. Now, what I mentioned is I want to multiply both sides of the equation by the LCD. So what I'm doing is I'm multiplying both sides of the equation by the same thing. And that is the multiplication property of equality, which we've dealt with solving equations. If you multiply both sides of the equation by the same thing, it's still equal. So it's true that the left side of the equation still equals the right side of the equation, because I've done the same thing to both sides of the equation. I multiplied it by the LCD. Okay, but what we notice is when we multiply by the LCD, something nice happens. And it's a property of LCDs that what will happen is all the denominators that exist in the entire problem will go into what we multiplied, the LCD, evenly. It's just a property of the LCD. The denominators will always divide the LCD evenly. Okay, so in this case, we'll notice that when we distribute the x plus 4 to the first term, which is this fraction here, we have x plus 4 times 2x plus 1 divided by x plus 4. And then we distribute it to the next term, x plus 4 times 3. What we notice is the x plus 4 cancels out with the x plus 4. And that's something you'll always notice, is that will happen. And this will result in 2x plus 1. And then we'll add the x plus 4 times 3, which is 3x plus 12. You distribute the 3 through the parentheses. And now the right side of the equation, we'll bring that down here. The x plus 4 cancels out with the x plus 4, and you're just left with negative 2. Okay, so at this point, what's nice when you multiply by the LCD and then after you simplify, the fractions are gone. There's no fractions remaining. That will always happen. So it may take a little bit of practice, but you want to get used to this, and you'll see that that will happen. All right, now all we have to do is complete the problem and solve. And the left side of the equation, we have some like terms. So the 2x plus 3x is 5x, and then plus 13 is equal to negative 2. We subtract 13, so we have 5x equals negative 15, and we get x equals negative 3. Okay, now there's something that you want to keep note of that they mention in the problem. So keep in mind that there are possible solutions that will not work. And something to keep note of is that it has to do with dividing by 0. Keep in mind that there are certain x values that just cannot work, that you may end up having at the end. So notice x plus 4 tells us that that x cannot equal negative 4. That's known as a restricted value. That's the value that x cannot equal. So x cannot equal negative 4 because notice when you plug in negative 4 in for x, you'll get negative 4 plus 4, which is equal to 0. That cannot be a solution. So you just want to check to make sure that that restricted solution did not appear in our final solution. As you can see, we got negative 3, so we know that this is a solution now. But it's probably a good idea to check your work by plugging negative 3 back into the original equation. It should work out though. Okay, now let's move on and work on part B. So we will find that the LCD is just this x minus 2, since it's our only denominator. And we're going to multiply both sides of the equation by x minus 2. And the right side of the equation, we will multiply by x minus 2. And at the very beginning, we could take into consideration the restricted value, like the x cannot equal negative 4. Notice that x in this case cannot equal positive 2, because 2 minus 2 is 0. So keep that in mind, that x cannot equal 2. So let's keep that in mind. All right, we'll distribute x minus 2, and we have 3x times x minus 2. And then x minus 2 times this fraction here. We'll notice we'll have just plus 4 because the x minus 2 cancel. And then notice that the x minus 2 cancels here, and we get negative 4x plus 12 on the right side of the equation. So again, the fractions are gone after you multiply by the LCD. We need to distribute here, and we end up getting 3x squared. 3x times negative 2 is negative 6x plus 4 equals negative 4x plus 12. Notice that we have a quadratic. Notice that we have a square term. So remember, when solving a quadratic from a previous section from chapter 1, I think it was 1.3, we we want to move the negative 4x and positive 12 to the left side to get it in standard form. So we have 3x squared. So add 4x gives us negative 2x. Subtract 12 gives us minus 8. It's equal to 0. And now we can solve. And this is the, we have a leading coefficient of 3. I'm going to use the AC method. And I'll do it up here on the top. So 3 times negative 8 is negative 24. And we'll factor this, and you check the different combinations. May not appear to you right away, but we'll notice this is negative 6 and positive 4. Add those up, we get negative 2. That's what we want, negative 2x. So we have 3x squared minus 6x plus 4x. So we have negative 6x plus 4x is replacing the negative 2x. We still have 3x squared and minus 8. And now we want to use the grouping. 3x, x minus 2 when we factor the first group. And then plus 4x minus 2, the second group. And then that gives us x minus 2. And 3x plus 4 is equal to 0. And then we solve, remember the product principle, or the zero product principle. We have x minus 2 is equal to 0 from the first set. And then we also have 3x plus 4 is equal to 0. And so from this first expression equal to 0, we have x equals 2. And then from the second set, we'll notice we'll have x equals negative 4/3. Notice that, remember, check our restriction. X cannot equal 2, remember, because we can't divide by 0. Notice we have x equals 2 at the end. That is not a solution. We can cross it out right now. And so we know that our only solution is a non-restricted value, which is x equals negative 4/3. All right, let me know if you have any concerns of this process. I'll be more than happy to help.